So you did mention physics as the first starting point. So general relativity allows for wormholes. They technically can exist. Do you think those can ever be leveraged by humans to travel faster than the speed of light?
Well,
or are you saying
the wormhole thing is debatable. We currently do not know of any means of going faster than the speed of light. There is there are some ideas about having space, so you can only move at the speed of light through space, but if you can make space itself move, that's warping space. Space is capable of moving faster than the speed of light.
Right.
Like the universe in the Big Bang, the universe expanded at much more than the speed of light by a lot.
Yeah.
But if this is possible, the amount of energy required to warp space is so gigantic, it boggles the mind.
So all the work you've done with propulsion, how much innovation is possible with rocket propulsion? Is this, you've seen it all, and you're constantly innovating in every aspect. How much is possible? Like, how much can you get 10x somehow? Is there something in there in physics that you can get significant improvement in terms of efficiency of engines and all those kinds of things?
Well, as I was saying, like really the Holy Grail is a fully and rapidly reusable orbital system. So right now, the Falcon 9 is the only reusable rocket out there. But the booster comes back and lands. You've seen the videos, and we get the nose cone or fairing back, but we do not get the upper stage back. So that means that we have a minimum cost of building an upper stage. You can think of like a two-stage rocket of sort of like two airplanes, like a big airplane and a smaller airplane. And we get the big airplane back, but not the smaller airplane. And so it still costs a lot, so that upper stage is, at least $10 million. And then the degree of the booster is not as rapidly and completely reusable as we'd like, and nor are the fairings. So, our kind of minimum marginal cost, not counting overhead per flight, is on the order of $15 to $20 million, maybe. That's extremely good it's by far better than any rocket ever in history. But with full and rapid reusability, we can reduce the cost per ton to orbit by a factor of 100. But just think of it like imagine if you had an aircraft or something, or a car, and if you had to buy a new car every time you went for a drive, it would be very expensive. It would be silly, frankly. Mm-hmm. But you just refuel the car or recharge the car, and that's makes your trip like 1,000 times cheaper. So it's the same for rockets. It's very difficult to make this complex machine that can go to orbit. And so if you cannot reuse it and have to throw even any significant part of it away, that massively increases the cost. So, Starship in theory could do a cost per launch of like $1 million, maybe $2 million or something like that. And put over 100 tons in orbit, which is crazy.
Yeah.
So
that's incredible. So you're saying like it's by far the biggest bang for the buck is to make it fully reusable versus like some kind of brilliant breakthrough in theoretical physics.
No. There's no brilliant break. No, there's no. You're going to make the rocket reusable. This is an extremely difficult engineering problem.
Got it.
But no new physics is required.